Hi everyone. So in today's lecture we are going to learn about the topic centroid and center of gravity. So let's start. So first we are going to understand this topic and we will explore every definition, differences and calculation step by step. So let's move forward. What is centroid? So here the definition of the centroid is the centroid is a geometric center or balance point of shape or figure. So let me explain you. The centroid is a point where a shape or figure balances perfectly. If it were made of solid material, it's like a center of mass of the shape in a triangle. For example, it's the point where all three medians intersect. It represents the average position of all the points in the shape. So in this mathematical meaning, it's computed as the mean of coordinates for all points. Let's move to the geometric importance. It means represents the balance point for a 2D object or uniform density. It means it represent about 2D object. Now let's move to the next topic. What is center of gravity? So let me explain you the definition of it. As you can see here, the point at which the whole weight of body is supposed to be concentrated irrespective of position of body. It means any object have center of mass or center of gravity where all the weight of the object is concentrated. Now relation to gravity, it depends on how mass is distributed and gravity acts through it. Now let's move forward. Physical meaning. It is a point of equilibrium for the gravitational force. So what's the difference between centroid and center of gravity? So let's move forward and let's see. So key difference between centroid and center of gravity. As you can see here, in centroid we have it based on shape geometry. It assumes uniform density and it is a mathematical concept. And in center of gravity we have it depends on mass distribution and it is a physical concept. It may differ in density various. So here are the differences of these two things. These both things, centroid and center of gravity, are closely related concept. Like the unit of centroid is position coordinates. For example, bar x or bar y. Same as the unit of center of gravity is also position of coordinates but relative to weight distribution. Let's move forward to our next topic. Why are centroid important? So as you can see here, why centroid are important? It helps in structural analysis, design, optimization, and simple calculation. So in structural analysis, centroid helps locate stress point in beam and framework. So it means the centroid is the geometric center of the beam or structure. It helps engineer in determine how forces and stress are distributed in bending. Stress is calculated from the centroid axis. The furthest point from the centroid face is the most stressed. Um, Knowing the centroid ensures the beam is designed to handle load safely. So now let's move forward. In design optimization, it helps balance component for better stability and efficiency. So let me explain you. Design optimization improves the performance and safety of structures, and it also helps balance components to avoid uneven stress or weight. A well balanced design ensures better stability and prevents failure. It also reduces material use and increase efficiency. And the engineers also use it to create strong and cost efficient and real, reliable systems. Now let's move forward. Simple calculation. So as you can see, it provides easy estimation for complex shapes using basic geometry. So of course, simple calculations allow engineers to estimate properties of complex shapes. They break down irregular structure into basic geometry figures. This make analysis quicker and easier without advanced tool. Okay, so now let's move forward. So now let's see the calculation. So calculating the centroid of simple shapes, we are going to see this step by step. So first step is we have to divide the shape into simple parts, whether it is rectangles or triangle. And in step 2, after dividing these parts, in step 2 we have to calculate centroid coordinates for each part. And in step 3 we have to use weighted average to find the total centroid. Okay, so now the calculation of centroid is complete. Now let's see the calculation of center of gravity. So for calculating the center of gravity, first we have to analyze mass distribution, in which we have to identify variations in density across the object. And in second step, we have to calculate moment of each mass element, in which we have to multiply mass by distance from reference point. And in the second step we have to find weighted average position, just like centroid, and in which some moments and divide by total mass. So we are done here from the calculation, and let's move forward. So now we will see our next point: applications in engineering and physics. So as you can see here, there are 3 points: structural engineering, mechanical design, and aerospace. So in structural engineering, the centroid helps design stable bridge and building. So of course in like structural engineering, or we can say civil engineering, it provides stability to bridges and buildings. And in mechanical design, center of gravity crucial for lifting and stability of cranes. And it is, as you can understand from the sentence, it also provides stability in lifting things, heavy stuffs from cranes and other things. And in aerospace, proper balance ensures smooth flight and safety. Okay, so now let's move forward to our last point: key takeaway and next step. So first we will see the summary here. Centroid, balance point of shape geometry. Center of gravity, balance point of weight distribution. So in simple language we can also understand centroid and center of gravity in these two sentences, and in short form. Now let's see the next step: practice calculating centroid of various shapes, and explore effects of mass distribution on center of gravity, and apply concept in real world engineering problems. So okay guys, now we are done here. Thank you for watching this video.